Hi, and welcome to this video. We're going to talk about deciding if an equation represents a function and a little bit about function notation. So the learning objectives are determining whether an equation defines a function and an introduction to function notation to evaluate functions. Let's go ahead and get started. All right, let's start with deciding if an equation is a function. And let's start with a nice linear equation here. Our first equation here is, I don't know where that came from. Here we go. That's weird. That's there. Okay. If y is a function of x, is y a function of x when y equals x minus 5? Is y a function of x when y equals x minus 5? So when we read this phrase, is blank a function of blank, this is going to be an output over here. Is our output a function of our input? Is our output a function of our input? So if we were going to set up a table of values, x would be our input and y would be our output. All right, so let's go ahead and just plug in some values and see if it feels like it's a function. So let's just pick a nice number. Let's pick x equal to 8. If x equals 8, then y equals x minus 5, so that's 8 minus 5, which would be 3. So 8 would take y to 3. Is there anything we can do to put in 8 and get a different number out? Well, not really, because we're just going to subtract 5 from it. So if we were to sort of thinking about undoing this, we know that whatever x is, y is going to be 5 less. So, if we plugged in a negative number, again, we would just get a much smaller negative number. Y equals negative 8 minus 5, which would be negative 13. So this does define a function. It's a nice linear equation, and linear equations are always functions. There's no way we can manipulate this to have two different values of y correspond to the same value of x. So the answer is yes. So linear equations are always functions. Let's look at another equation. Is y a function of x when y squared equals x minus 5? And I'm guessing you're probably already thinking this looks weird, because we usually don't see a squared value on the left-hand side of your equations. Usually it's y equals and maybe the squared is on the other side. So this one says y squared equals x minus 5. And let's just think if we can figure out some values that might cause us problems here. So let's pick x equal to 9. Let's just pick x equal to 9 and see what happens. So if x is 9, then y squared equals 9 minus 5. So y squared equals 4. Now, can we think of two values that square to get 4? And sure enough, we can, because 2 squared is 4, and negative 2 squared is also 4. Negative 2 times negative 2 is positive 4. So 9 goes to 4, but 9 also goes to negative 4, which we know is not a function. That's a problem. Same input, two different outputs. All right, and let's look at the last one. Is y a function of x, so same inputs and outputs, if y minus 1 equals x minus 5? Well, this one's a little more complicated. Oops, I don't know what I hit there. A little more complicated from the first one, but not terribly so, because we can move this negative 1 by adding 1 to either side of our equation. We have y equals x minus 5 plus 1, x minus 4. And now we're back to a nice linear equation. This one just subtracts 4 from each input. The first one subtracted 5. But you can see from the pattern that this is still a linear equation and it is a function. All right. So really, when you're looking out for these, is it a function? If you see a y squared, you should be pretty concerned. Let's go ahead and start talking about function notation. So function notation is a pretty useful tool we have to deal with evaluating functions. When we look at function notation, we write y equals f of x. And we say f is a function of x, or we say f of x for this right here, f of x. It's not multiplication. We don't always have to use f. We can use other variables. We could use v of t, g of z, h of d. Most of the time we use f of x, or lots of times we use f of t. T is a very common independent variable as well. And in general, we say f of some input gives some output. So let's practice using function notation with an actual function. So here's our example using function notation. We're going to do it for four different values. So up here is where we define our function f of x is x squared minus 2. So this tells us what to compute. It says take your input x, this is my input, and then what you're going to do to it is you're going to square it and subtract 2. That's the rule that this function is telling us. So if we want to know what is f of 2, the rule says square it and subtract 2. All right, so f of 2 would be equal to, well, we can use the rule in our head, but we can also have the notation help us so we don't have to talk out every single equation that we want to deal with this. Everywhere we see an x, we're going to go ahead and put a 2. So f of 2 is 2 squared minus 2. Where I saw the x, I put the 2. So this was my input of x, and everywhere I saw the x, I put 2. And now I just follow my order of operations, my PEMDAS, and I can simplify this value. So f of 2 equals, well, there's a square and a subtract, so I'm going to do the exponent first. 2 squared is 4. So f of 2 equals 4 minus 2, which is 2. All right, let's try f of 0. So now I've replaced my input of x value of to be 0. So now everywhere I see an x, I'm going to put a 0. So 0 squared minus 2, using my same rule of f. I haven't defined a new f. So f of 0 equals 0 minus 2. F of 0 equals negative 2. All right, I'd like you to pause the video now and try to find f of negative 2 using the same function I've defined up here, and this time our input is negative 2. Pause the video, give it a try, and come back. All right, were you able to figure this out? This one's a little bit trickier because you have to be careful that you square negative 2. It's very tempting, and I'm actually going to write this wrong really quick and then scratch it out, so I'll put it in black wrong. You want to go negative 2 squared minus 2, and this is incorrect because my x value is negative 2, and that's what's squared. So this would give me, if I follow my order of operations here, this would be give me negative 4 minus 2, which would be negative 6. But this is wrong. I'm going to Ghostbuster it here. It's wrong because I didn't plug in my negative 2 correctly. What I should have done was negative 2 in for the whole x, which is squared, minus 2. Negative 2 squared is negative 2 times negative 2 is positive 4 minus 2. 4 minus 2 is 2. So we get the value of 2 again. And that's okay because we can have multiple outputs the same as long as each input leads to exactly one output. All right, now for fun, you guys are like fun, let's do f of circle with an x in it. All right, so now my input instead of x is circle x. So everywhere I see x, I'm going to put in this symbol. And that would be the answer. We can plug in anything we want. We could do f of smiley face if we wanted to. It would be, I'm not good at drawing, smiley face squared minus 2. Now, obviously, we're not going to do a lot of f of smiley faces or f of x with a bar in it, but we are going to sometimes do things like f of a constant that we don't know, maybe f of c. And that would be c squared minus 2. So you will see examples where we put in a constant. Let's do another example. All right, we're going to do this example 3 of using function notation. Our function is going to be new. We're going to call it g this time. G of x equals, and this means the cube root of x. So the square root means that you square the number to get it. The cube root means you cube the number to get it. So for example, let's look at what the cube root, this is just an example to remind you what cube roots are. Let's think about the cube root of 27. Okay, well, we have to ask ourselves what times itself 3 times gives us 27. Well, 1 times 1 is 1 times 1 is 1. 2, 2, 2, 8. 3 times 3 times 3, 27. So the cube root of 27 is 3. And the tricky thing about cube roots over square roots is you can take them of negative numbers. So if we wanted the cube root of negative 27, it would be negative 3 because negative 3 times, I don't want to write it that way, sorry. It would be negative, oh, I thought I hit the eraser. It would be negative 3. And the reason for that is because negative 3 times negative 3 times negative 3 is negative 27. So we have an odd number of integers there. So we're able to have cube root of negative numbers, but you can't take the square root of negative numbers because there's no way to multiply something by itself twice and end up with a negative. All right, well, let's go ahead and jump in and figure out, why don't you pause the video, give it a try. Why don't you try to find g of 8 and g of 0? All right, you back? Let's check your work on g of 8 and g of 0. So g of 8 would be the cube root of, and everywhere I see an x, I put an 8. The cube root of 8 would be the number times itself 3 times. That gives you 8, which we all know is 2. Because 2 times 2 is 4 times 2 is 8. All right, so g of 8 is 2. G of 0, I'm kind of squished up here, so I'm going to rewrite it, is the cube root of 0. Well, 0 times 0 times 0 is 0, so we're back at 0. Let's keep going. The cube root of negative 8 would be negative 2, because negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. And finally, and a little more abstract one here, the cube root of, and everywhere we see an x, now we just put an a. And that's not super satisfying. Maybe you want to get back to a number, but we're going to be using this a lot as you progress in mathematics, where we're not going to be actually putting in numbers. We're just going to be wanting a constant to be there or something else. So we've got to get used to being a little bit more abstract there. All right, that's the end of this video. See you next time.